A Miocene landscape might feel strangely familiar, and yet something is off. This was an age when hoofed mammals experimented with forms and lifestyles that have no true equivalents today. Why did so many unusual shapes emerge? And why did so few of them persist? Open grasslands, scattered forests, herds of grazing mammals moving across the horizon. The Miocene was a crucial chapter in ungulate evolution. Poorly appreciated but deeply fascinating ungulate species with strange adaptations roamed the landscapes. Among the most intriguing were the Hipparianine horses, an extinct branch of equids that still retained 3 toes on each foot. Within this group, proboscid Hipparion stands out as particularly unusual. Unlike modern horses, it may have possessed a short, flexible proboscis, an adaptation likely linked to feeding. In dry or dusty environments, such a structure may have helped it grasp vegetation or filter out particles, offering a different solution to the challenges of grazing and browsing. Elsewhere, in Eurasia, another ungulate pushed the boundaries of form in a very different direction. Kubanochoerus, often described as a unicorn pig, bore a large bony protuberance on its forehead. This structure may have supported a keratinous horn, possibly used in display or combat. What pressures led to such a feature? Competition or sexual selection? Maybe both. Its presence suggests a world where visual signals played an increasingly important role. In North America, a relative of modern pronghorns took ornamentation even further. Rhinoceros carried branching horns reminiscent of deer antlers, yet with a striking asymmetry, the right horn larger and more elaborate than the left. This uneven development raises questions about behavior and display. Was this asymmetry advantageous, or simply a byproduct of rapid evolutionary experimentation? South America, long isolated from other continents, produced its own distinctive ungulates. Among them was Homolodotherium, an animal with distant affinities to perissodactyls, but shaped by convergent evolution into a form unlike any modern hoofed mammal. Its body plan and limb structure recall, in some ways, the Calicotheres, another group that defied expectations. And indeed, the Calicotheres themselves represent one of the most unusual branches of ungulate evolution. Calicotherium, despite being related to horses, tapirs, and rhinoceroses, abandoned the typical hoofed stance. Its forelimbs evolved into powerful clawed appendages. Instead of grazing, it likely pulled down branches, feeding on leaves in a manner more reminiscent of some large herbivorous mammals that grasp vegetation rather than crop it. A similar ecological theme appears in Miocene, a tylopod distantly related to modern camels. Yet it looked nothing like them. Its body resembled that of a pig or a tapir, complete with a short proboscis. This suggests a browsing lifestyle in which selective feeding and manipulation of vegetation were key. In Africa, early relatives of giraffes were exploring their own morphological possibilities. Prolobitherium combined a body reminiscent of an antelope with broad, flattened ossicones that spread across the head. These structures, unlike the horns of modern bovids or the ossicones of giraffes, created a silhouette that must have been striking. Their function likely involved display, signaling, or competition. In coastal environments, a very different kind of ungulate radiation was unfolding. Paleoparadoxia, a member of the enigmatic Desmostylia, occupied shallow marine ecosystems along the North Pacific Rim. Despite its unusual appearance, it has been interpreted as part of a broader group of mammals that may share distant affinities with perissodactyls, the lineage that includes horses, rhinoceroses, and tapirs. Its lifestyle, however, was entirely different. Paleoparadoxia was an aquatic herbivore, spending much of its time in coastal waters, where it likely fed on seagrasses and algae. Its body was heavy and well suited to buoyancy control, and it may have moved slowly through the water or along the sea floor, foraging in a manner sometimes compared to large semi-aquatic mammals. Taken together, these animals reveal a deeper pattern. The Miocene was not simply a time of diversification, it was a time of exploration. Hooves became claws, snouts became proboscises, and horns took on shapes both symmetrical and uneven. Different lineages responded to similar ecological pressures in different ways, often converging on comparable solutions or diverging into entirely novel forms. And yet, most of these experiments did not endure. As climates continued to shift and ecosystems changed, many of these unique lineages disappeared, leaving behind only fragments of their diversity. The ungulates that survive today represent just a narrow selection of what once existed. The Miocene reminds us that evolution is not a straight path toward familiar forms. It is a landscape of possibilities, some fleeting, others enduring. In that landscape, even the most unusual creatures once thrived, shaping ecosystems in ways that are only now being rediscovered through the fossil record.